2.1 Properties of Radical Functions, and now we're going to do cubics. So just like the other things that we've done, you would have the graph first and then you will square root your answers. So first let's do the domain and range of f of x. So x is going to be an element of the real numbers, and range is also going to be element of the real numbers for both of them. So that works for both. Okay, let's graph it now. So I'm going to see my invariant points first, so that's going to be my x-intercepts. And then I'm going to go to where there is 1, and not -1 because we can't go negative. Alright, now it gave us a couple points. We could do this 4 and make it into a 2. So there's that point. So this side of the graph is easy. It looks like that. It gave us this point so that we can effectively square root it. So if I take the square root of 0.325, we always square root the y values, the x values don't matter, I get 0.57. So it actually gets a little bit bigger. So on the inside here, it's going to go like this, up. So let's do our domain and range now. So for domain, it's going to be piecewise. We got from here to here, so we could say x such that -1 is less than or equal to x that's less than or equal to 0, or it could be greater than this point for all the real numbers. And for our range, because this part of the graph goes up forever, it's going to be greater than 0. We don't have to worry about this boundary right here. So there is our domain and range. Okay, this graph, we're going to plot our x-intercepts because those are invariant points. Then I will plot 1 because that is also invariant point. I'm also noticing that up here it's going to hit 4. So it's going to hit 2 down here. So on this side, our graph will look like this. It gave us this point, 0.125. So let's square root that, and I would get 0.35. So it's going to get slightly bigger here. So there's our graph. So there isn't actually a gap in this one. So we just have to say that x is bigger than -1 because there's no space in between there. Our range, we just have to say is bigger than 0. So like quadratics, there's going to be a whole bunch of different combinations for cubics. Lines are pretty easier. It's just less than or greater than your intercepts. But cubics and quadratics, this should say cubic by the way, they're a little bit more work. Okay, solving a radical equation graphically. So this isn't my favorite way to solve things because you have to use Desmos, and I just don't feel like that's a lot of work. But we will do it. So what you're going to do when you have an equation like this is you're going to move everything to one side. So +6 and then minus x equals 0. And then this is what you're going to plug into Desmos. And this is going to tell us the answer. The answer is going to be the x-intercept. Your solutions are always your x-intercepts, unless it's asking for like a maximum or a minimum. It'll also help us do our domain and range. So I want you to pause the video, type that into Desmos, and see what you get. So it should look like this. So we can easily find the solution. So the solution is this. So x equals 12.217. Now we can do the domain and range. So domain, oh, I didn't plot this point right here, but this point is at -0.66 and 6.71. I forgot to highlight it. So for our domain, we would say x such that x is greater than or equal to -0.66 for all the real numbers. Our range has to be lower than this point. Oh, I just drove through it. Lower than this point. So our range is y such that y is less than or equal to 7.414. And that's everything. Alright, and just know that it can go down here because there's more to the equation than just a square root, if that was confusing you. Alright, bye!